Hello, my juniors. This is Miss Sanchez from chemistry class. We open the second partial with a new lesson titled Introduction to the Periodic Table. On Thursday, I received your diagnostic tests. Thank you very much. And there is a report which was given to academic coordination on Friday. This report has your complete name and last name, the email address you used to send the attachment, the hour at which you sent the attachment, and the score you have. It is not worth in percentage, but instead it is scored according to the amount of questions you have correct. It is very important to note that we have deadlines to give our assignments. The report has detailed the hour at which you sent your assignment, so we can keep a record of those students that sent it before 2:30 and those students that sent it after 2:30. And this is the way that we are going to work in the second partial as well. If you have a deadline for an assignment, please make sure to organize your time very well. Be prepared for the class, checking your platform frequently so you send all your works in time and manner. I'm afraid that those that send the assignments after the deadline can have a lower grade or can be taken out the entire grade for the homework or classwork. As usual, we open our lesson with a questionnaire that we should answer in our notebook handwritten, leaving 5 spaces between question to question should be enough. When you are done doing your questionnaire, please write your first name and your first last name in ink on the heading of each notebook page. Take pictures of the entire guide and organize these pictures in a PowerPoint presentation. Save it with your first name and your first last name, that is the name of the file, and then don't forget to send the attachment of the PowerPoint presentation to the email address that I have, which is mt.sanchez@sanjosedelcarmen.edu.hn. The deadline to send both the biology and the chemistry notebook guides is going to be Saturday, April 25. Don't forget, Saturday, April 25 is the last day you have to send your guides. Here is the guide, which you can pause the video, of course, to copy the questions complete and correct. This lesson is dedicated to all our mothers for their love and dedication. In a few moments, we are going to study why exactly we are dedicating this lesson to our beautiful moms out there. Chemists in the past began to organize the known elements. A few elements, including sulfur, copper, silver, and gold, have been known for thousands of years. Yet, there were only 13 elements identified by the year 1700. chemists suspected that other elements existed. As chemists began to use the scientific method to search for elements, the rate of discovery increased. In one decade, that is from 1765 to 1775, chemists identified 5 new elements, including 3 colorless gases: hydrogen, nitrogen, and oxygen. Chemists began to ask themselves if there was a limit to the number of elements, or if there were elements that they had not discovered yet. To begin to answer this question, chemists needed to find a logical way to organize the elements. Early chemists used the properties of elements to sort them into groups. One of the first people to try to organize the elements was Johann Dobereiner. Johann Dobereiner was a German chemist. He had made one of the first attempts to classify elements, and he published his classification system in the year 1829. His method consisted in classifying them into groups of 3, which he called triads. So triads were elements that had similar properties, and one of his triads was that made of what we know now today as the halogens, and those are chlorine, bromine, and iodine. But in the year 1869, Mendeleev published a version to classify the elements that was accepted in the scientific community. In his method, he used cards to write down the properties of the elements that were known at that time. We are talking about the 19th century. Dmitri Mendeleev was a Russian chemist who developed the accepted periodic classification of the elements. If we take a look at one of the first versions of the periodic table published by Mendel, we see elements designated by 2-letter symbols organized in a chart. Here we can see magnesium or aluminum, the symbol for zinc, the symbol for silver. But if we are an observer, a good observer, we notice that in the 3rd row there are elements with the atomic masses 68 and 70 that do not have a 1 or 2-letter symbol, but instead have a question mark. These question marks meant that he predicted the existence and the properties of these elements, though they had not been discovered. Actually, it would take decades or even a century to complete the periodic table as we know it today. You may remember how we opened the lesson dedicating it to our mothers. And has to do with the story of Dmitri Mendeleev and his mom. And the story is called My Mom Believed in Me. Dmitri Mendeleev grew up in a very cold place called Siberia in Russia. His dad was a professor of St. Petersburg University, and actually, when he was alive, they lived a pretty comfortable life. He had many siblings, and they were well cared by mom and by dad. But unfortunately, when Dmitri Mendeleev turned the age of 13, his daddy died. When his daddy died, Dmitri Mendeleev and his brothers and sisters lived a very poor, low-quality life. In an attempt to send her children to school, Dmitri Mendeleev's mom reopened an abandoned glass factory. But 1 year later, the glass factory caught fire. However, Dmitri Mendeleev's mom had a deep belief that he was a gifted child, and she dedicated the following time of her life trying to change the future of Dmitri Mendeleev. So she packed her belongings and the belongings of Dmitri Mendeleev and rode in horse through the cold and isolated mountains of Siberia. And they reached the University of Moscow. In the University of Moscow, Dmitri Mendeleev's mom begged the deans to accept Dmitri Mendeleev as a student. But her attempt failed, and the University of Moscow denied Dmitri Mendeleev a scholarship to study there. But Dmitri Mendeleev's mom was not willing to give up. So she rode a lot of miles with Dmitri Mendeleev on top of the horse to another university, the university where her husband and Mendeleev's dad was professor when he was alive, and that's St. Petersburg University. There, she begged once more the deans of the university to accept Dmitri Mendeleev, and they said yes. So Dmitri Mendeleev received a scholarship at St. Petersburg University. Soon after she completed her mission of sending Dmitri Mendeleev to school to a prestigious university, she died. And this is why we dedicate this lesson to our moms, because they are a very special part of creation, and they are willing to do many sacrifices so that we can have the very best. Exodus 20:12 tells us, honor your father and your mother, so that you may live long in the land the Lord your God is giving you. Exodus 20:12. This passage is part of the 10 Commandments given to Moses in Mount Sinai. And what is so special about this commandment in particular is that it is the only one accompanied by a promise. God commands us to honor our father and our mother, but when we do so, He is promising something as well. He is promising that we are going to have a long life in the land He is giving us. Today's periodic table contains elements that were discovered after Mendeleev's death and integrated into the chart. So, as an introduction to it, we are going to study two concepts that are part of the anatomy of a periodic table. To begin with, we have these vertical columns, and we call these vertical columns groups. We also have these horizontal rows, and we call these horizontal rows periods. So remember, vertical columns from top to bottom are groups, and horizontal rows from left to right are called periods. Excellent. In the modern periodic table, elements are arranged in order of increasing atomic number. When elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. Next is classifying the elements. Here we're going to study from 2 to 4 characteristics of each vertical column or row, and we're going to discuss 2 examples of uses that the elements in each group has. So let's begin. You have a question asking you to draw and label a periodic table square, and this is the example. The example is with aluminum. So what is on top that says 13 corresponds to the atomic number, which at the same time is the amount of protons present in the nucleus of an atom of aluminum. Next, where it says Al, we are referring to the chemical symbol. The chemical symbol consists of 1 or 2 letters, where the first letter is uppercase and the second letter is lowercase. Below that, we have aluminum, and aluminum is the name of the element. On the bottom of the square, we have this decimal integer that, as you know from the laboratory practice, was calculated after a procedure where you average the atomic masses of the different isotopes of aluminum. Atomic mass in a very simplistic form is the sum of the protons and the neutrons present in the nucleus of an element. To finish, in the upper right corner, we have the numbers 2, 8, and 3. And these numbers correspond to the amount of electrons that fit in each energy level. Remember, they can be calculated using a very simple formula that is 2n to the square, which we did in class, where n corresponds to the energy level we are trying to find out. Please open your chemistry textbook in pages 168 and 169 so we can begin our discussion of the groups. So the first group is group 1A. If you already have your chemistry textbook in hand, place your finger in all the vertical column of 1A. So in group 1A, the first member that appears in blue is hydrogen. Hydrogen is a unique element that has only one proton and one electron with no neutrons in the nucleus. Hydrogen is the smallest chemical element because it consists of only one proton in its nucleus. Hydrogen is the most abundant chemical substance in the universe, and though it is a nonmetal, it is together with members of group 1A that are metals because it forms a 1+ ion when it loses its only electron. Next is group 1A, or alkali metals, that are in the same with hydrogen, but these are metals and hydrogen is a non-metals. The only thing they share in common is that both react in a way that they get rid of one electron and they donate this electron to another element, usually a nonmetal. So this is the position of alkali metals in the periodic table. Notice that the first square is in white because it corresponds to hydrogen, and hydrogen is a non-metal. Alkali metals are soft, gray metals. This is why we see in the picture that the person is cutting it into pieces with a knife because it has a soft consistency. They are good at conducting heat and electricity. They easily react with water or oxygen, and for this reason, they are never found in its pure state in nature, but instead chemists have to isolate them. Number 4 is that they have one valence electron, or they have this electron in the outermost energy level that they can donate, and when they donate or they get rid of that electron, they form ions with a charge of 1+. These are examples of alkali metals and their uses, not in its pure state but combined with other elements. A compound containing potassium, this is potassium chloride, is a key ingredient of fertilizers. Example number 2 is sodium. In ancient times, common salt, or sodium chloride, was very important, and it was exchanged using the same value as gold. Again, Sodium in its pure state doesn't exist in nature, but sodium combined with another element, in this case chlorine, forms common salt. Common salt was so important in ancient times that the word still is around. When your mom and your dad receive a salario, un salario, or the money for each month, that refers to sal, because salt was a very valuable material in ancient times, especially to conserve food since there were no refrigerators. Next in the list is group 2A. So put your finger in group 2A. In group 2A, we have the elements beryllium, magnesium, calcium, strontium, barium, and radium. Alkaline earth metals have this location in the periodic table. They're group 2A. And these elements are less reactive than alkali metals. They are also heavier than alkali metals, and they have 2 valence electrons and form ions with a 2+ charge. The first example is a compound containing the alkaline earth metal magnesium. In this case, magnesium hydroxide is a key compound in milk of magnesia, which is a commercial antacid. Milk of magnesia is a medication that is used by those that may be suffering from conditions like where they have a peptic ulcer and they feel a hot burning sensation in their stomach, which is caused by the gastric juices that are damaging the stomach walls. So magnesium hydroxide is used as an antacid that reduces these burning sensations in the stomach. Next is calcium, and calcium is important to build solid bones. If there is calcium deficiency in diet, the body takes calcium from the bones to ensure normal cell function, and this can lead to weakened bones. So here we have a diagram that shows a sagittal cut of a bone, the bone that attaches your hips and your legs. This is a bone in your upper leg. And we can appreciate how the tissue is way more dense than it is here. And this is because this is a sick bone that has calcium deficiency. And we know this condition as osteoporosis. Next is group 3A. Group 3A has this location in the periodic table. So if you are in page 169, group 3A is the one that has the following elements: boron, aluminum, gallium, indium, thallium, and anuncium. The metallic character of these elements increases with the atomic number, and they have 3 valence electrons and form ions with a charge of 3+, especially aluminum. One of the examples we are going to discuss is thallium, which has an atomic number of 81. In the last century, the 20th century, thallium was used as part of the ingredients of rat poison. But its use was discontinued because workers that manufactured this rat poison that had thallium had severe intoxication that manifested in symptoms like red skin and psychosis episodes. Next is boron, our second example of group 3A, which has an atomic number of 5. A compound that has boron, called boric acid, is a moderate antiseptic used as an eye wash. Next is group 4A, and group 4A is the one that has the following elements: carbon, silicon, germanium, tin, and lead. The metallic character of these elements increases with the atomic number, just as in group 3A, and they have 4 valence electrons. One of the most important members is carbon with an atomic number of 6, and this is because there are around 24 million natural substances containing carbon that have been identified. Carbon is so important that we have 2 entire partials, well, more than 2. We have 3 entire partials in your 10th and 11th grade dedicated just to carbon chemistry. Next example is silicon, which has an atomic number of 14. Silicon is very important in the technology industry, and it is used in computer chips. In fact, silicon is so important in the technology industry that there is a city in the United States, which is the Senate of all the technological companies, called Silicon Valley. Next is group 5A, and group 5A has the members nitrogen, phosphorus, arsenic, antimony, and bismuth. The elements that make up this group are very different in their physical and chemical properties, and it includes elements with non-metallic character. That's the case of nitrogen and phosphorus. It includes metalloids, which can have characteristics of metals and non-metals depending on the environment at which they are handled, and these are arsenic and antimony. And they have a heavy metal, which is bismuth. Our first example is nitrogen. Nitrogen is a gas at room temperature. In fact, the atmosphere has a great percentage of nitrogen. But at very low temperatures, very, very low temperatures, that is approximately 195 degrees below zero, note the negative sign there, nitrogen becomes liquid, it changes of state. And because of its ability to maintain very low temperatures, it is used to preserve biological material for a long time for later study. Next example is a compound containing bismuth, which has the atomic number 83. Bismuth subsalicylate, sold under the brand name Pepto-Bismol, is an anti-acid medication used to treat temporary discomforts of the stomach and gastrointestinal tract. These discomforts include diarrhea, indigestion, heartburn, and nausea. Next is group 6A. Group 6A contains the members oxygen, sulfur, selenium, tellurium, and polonium. The properties of these members are actually very different, and what they have in common is that they all have 6 valence electrons. That is why they belong to the same group. Oxygen is one of the members. It has an atomic number of 8. And oxygen is very important because it is consumed by cells during metabolism in humans and actually in most organisms, plants, and in most organisms, especially animals. Plants, instead of requiring oxygen, they do need great concentrations of carbon dioxide because for plants, oxygen is a byproduct, or in other words, plants produce oxygen and consume carbon dioxide. Animals don't. Animals consume oxygen and produce carbon dioxide. Polonium is next example, and it has an atomic number of 84. Polonium is special because it is a radioactive element, and this means that you have a piece of polonium in front, and you apparently there's nothing wrong with that, using no protection, but it emits invisible alpha and gamma radiation. Alpha and gamma radiation exposure is dangerous because they are waves that are highly energized, that when they hit your tissues, they have the energy enough to break DNA strands and change the configuration of the molecules that make up our cells, leading to the appearance of different diseases, especially different kinds of cancers or leukemia, babies born with genetic mutations. It's all because of the exposure to ionic radiation. For this reason, polonium is dangerous and should be handled with care. To the left side, we have the chemist Marie Curie, and Marie Curie was the person to discover the element of polonium next to her husband. Because she did not know about the radioactive properties of polonium, she didn't use protection, and she eventually died from a disease in her blood that was caused because of exposure to radiation. Next is group 7A, and what we see in picture was a terrorist attack where the people planning it put a chemical weapon made up of chlorine. Group 7A corresponds to a group known as the halogens. The Spanish word for halogens is halógenos, and it includes members like fluorine, chlorine, bromine, iodine, and astatine. Known as the halogens, which means those that form salt, So this is a connection to biology. If you remember halophiles, where we said that those were prokaryotic organisms that resist high concentrations of salt. Here we see the prefix again. They're called halogens because when they react with metals, especially from group 1A, they form salts. They have 7 valence electrons, and they are too reactive to be found in its pure state, meaning chemists have to isolate them in laboratory conditions to study them alone because they are usually already bonded with some other element in a compound. One example of group 7A is fluorine. So fluoride is an essential ion for animals, strengthening teeth and bones. It is added to drinking water in some areas. Actually, in Honduras, Sana used to add fluor or fluorine to our water because for a long time we thought that it was good for the health of our teeth. But actually, research then proved that fluorine in incorrect concentrations does the opposite, and it causes damage of dental pieces. So we see here the before of a person using a treatment with fluorine and the after. We can see that the teeth are very brittle and very stained after the use of this substance. Next is chlorine, and chlorine is commonly used as an antiseptic. We have been listening a lot of chlorine lately to disinfect the objects in our house. But remember that is to be used with a lot of prudence because chlorine can also be dangerous if used in incorrect concentrations. And it is used to make drinking water that is safe, but in concentrations that are controlled by the treatment plant, and also to treat swimming pools. Next is group 8A. Group 8A is known as the group of the noble gases and has members that include helium, neon, argon, krypton, xenon, and radium. Noble gases exist in their gaseous state and do not tend to participate in chemical reactions with other elements. All noble gases have their outermost energy level full with their electrons, and for this reason, noble gases are not going to form compounds with other elements, but they like to be alone because they don't need to receive or donate any electrons. They have all their energy levels are already full, so there's no space for another extra electron, and they don't want to get rid of electrons in their outermost shells because they have the complete correct number they should have. One of the uses of noble gases is krypton, and krypton is used in some types of photographic flashes, used in high-speed photography. Noble gas krypton with atomic number of 36. Next is neon, and neon is used as an economical refrigerant. So neon has the atomic number of 10, and it is used as an economical refrigerant. To finish for today, we have the transition metals, and the transition metals are not one group in particular, but if you have your periodic table in the book, pages 168 and 169, the transition metals are those that belong to groups 1B to 8B. So all these groups are called the transition metals. They have a hard consistency and they tend to break easily. and they are a lot less reactive than alkali metals and alkaline earth metals. So it's easier to find them in its pure state. All these that are colored in yellow are the positions to locate transition metals. Notice it's a big group and it is not. Notice that it is very big, but it is not one group in particular. One vertical column in particular, but instead is a union of many vertical columns of many groups in the periodic table. One of these is iron. Iron has an atomic number of 26, and it is very important to animals and humans like us because iron is required to make a protein. You remember how we talked about proteins in biology class? A protein known as hemoglobin. Hemoglobin is a protein that may be represented in a diagram like this. And what's important to note is that hemoglobin is like a taxi that transports oxygen that we inhale from the atmosphere and takes that oxygen to the rest of the tissues in our body. When there is deficiency of iron and therefore deficiency of hemoglobin, that causes conditions like anemia. And one of the main symptoms of anemia is fatigue and also strong headaches and lack of appetite. When a person has anemia, the doctor prescribes iron supplements, like this one over here that says hierro líquido. But it is very important to note that if we are taking iron supplements, then we should hurry to the bathroom and wash our teeth immediately because iron causes severe tooth decay. It's common that we see a child that has very brittle dental pieces that are very stained, and sometimes the child has lost dental pieces already. And this is because the parents of the child didn't know how to properly manage iron supplements. So the iron supplement remains that were in the mouth of the child caused the teeth to rot. Hizo que se pudrieran los dientes. So remember, if you're taking iron supplements, especially if it's a syrup, si es un jarabe líquido, then it is very important that you brush your teeth immediately so that they don't rot, para que no se pudran los dientes. Iron, be careful with that. Last for today is gold, our second example of transition metals, and that has an atomic number of 79. So gold is, we all know gold because it's very precious metal in the commercial sense. But what very few people know is that gold does have medical applications. I'll mention to you just one. Small amounts of gold are used to remedy a condition known as lagophthalmos. If you ride a bus, then maybe you see your friends when they are sleeping in the bus. Some of them may have lagophthalmos, which is when the person has an inability to close the eyes completely. Instead, when they think they're closing the eyes, you can still see the white part of the eyes. And this is caused, it's not a disease actually, it's not a disease, but it can cause a little bit of dryness to the eyes if you're not blinking because you're asleep. And it is caused usually because the skin of your eyelid is like a little short. so it doesn't extend to allow your eyes to close fully. Now, this condition can be remedied if doctors implant gold weights in the eyelid. Son como pesitas y son hechas de oro. And so they are inside the skin of your eyelid, and they, because of gravity, they force the skin of the eyelid to be elastic enough to make your eyes close completely when you are asleep or when you blink. So it's very curious, and it looks very, very disturbing, especially on this picture over here, where you see the doctor doing the procedure of inserting the gold plate inside the skin of the eyelid of this person, as to make this person close these eyes completely because of the force of gravity. All right then, guys, this is it for today. God bless you so much, and I hope to see you further in the week for the next chemistry lesson. Bye bye now.